MAT0018 review for final exam, and we're starting with problem 49. We're going to solve some percent problems. In our class, we solve these percent problems as equations. So we're going to use the P times B equals A formula. P is your percent. You have to plug it in as a decimal. B is your base. It's the thing you take the percent of. A is your amount. Of is times, is equals. So for each one, I will try to plug into that formula. So what is 30% of 17? So I will write my formula. The percent is the easiest one to spot. It either has the percent symbol or it has the words. So we have 30%. We have to convert to decimal form. So drop your percent and move the decimal 2 places to the left. So 0.30 or 0.3. Continue from there to find your base. Whatever you take the percent of is your base. So the 17 is going to be your base. 30% of 17. So times 17. That only leaves our A. The A will always be at the front or the end. It's not at the end, so it must be at the front, isolated by is. Here's your is. There it is. Then you work with your equation. Our A is already isolated, so we're just going to do the multiplication on the left-hand side. 0.3 times 17. And remember to count in decimal spaces. So 5.1 equals A. You can see if it's reasonable. 30%. So that's not even a half. That's a little bit more than a quarter of 17. About 5, that's reasonable. If I had the decimal in the wrong place, 51, no, that would be way too big. So that can help you find a decimal error if you think of that. So 5.1 equals A. Next we have 30 is 5% of what number? So it's still a percent problem, looking for a percent, so we will use our formula. P times B equals A. And we'll look for our pieces. The percent, 5%, we're going to convert to a decimal. So we drop the percent and go 2 places to the left, 0.05. Next, we look for the base. The base will come right after the percent. So you keep reading 5% of what number? This time we don't know the base, so we will keep a variable for that. Right, so our A is not at the end. It must still be at the beginning. Here's the is. It's the only thing there. Now you have a plain equation. We want to isolate the B. It's multiplied by 0.05, so we're going to divide on both sides by 0.05. Once you have calculators, this will be very easy. You will punch it in top to bottom, 30 divided by 0.05. For this class, we did not have calculators yet, so we have to do a long division with decimals. 0.05 into 30. Remember, get your decimal out of the divisor. You have to divide by a whole number. Underneath, you have to move the same direction, the same amount of spaces. Right now, you're at the end. Has to go to the right 2 spaces and then go up. Then you're ready to divide. So we're going to do 5 into 30. We'll go 6 times. Make sure you line up. Multiply back. Subtract. Bring down. 5 into 0 won't go. And bring down. 5 into 0 won't go. So we'll go all the way up to the decimal. B equals 600. Let's see if this is reasonable. 5%, so just a little tiny bit of 600 is 30. That's reasonable. We have one more percent problem. 264 is what percent of 33? So we'll use our formula again. P times B equals A. Look for our pieces. First we'll look for percent. This time that is our unknown. So we'll keep a P. Next we'll look for the base. Go right after the percent. What percent of? The next piece is your base. So our base is 33 this time. Your A this time is at the beginning. 264, there's your is. Isolated by is. Now you have a plain equation. You're going to isolate your P. It's multiplied by 33, so you're going to divide. So again, with a calculator, this would be easy. We don't have a calculator, so we'll have to work a little bit. Our P will be 264 divided by 33. So a long division, 33 into 264. And we're actually going to have to divide all the way into 264 because it won't go into 26. I think this will go 8 times. Multiply back. 8 times 3 is 24. 24, 25, 26. So it does go 8 times. Now, one thing you have to watch out for. When you solve for percent, it takes one more step than the other two kinds of problems. Because remember what we plugged into this P in the formula was a decimal. So we don't really have percent form yet. We have a decimal form. To get from a decimal to a percent, it's like multiplying by 100%. Your decimal is going to move 2 places to the right. So 2 places to the right and add your percent symbol. Well, 800%, you might be bothered by that. That's really big. Let's see if it's reasonable. Remember, 100% of something would be the whole thing. So 100% of 33 would be 33. So 800% is going to be 8 times this is 264. That's reasonable. All right, for our last problem, we're going to switch gears a little bit, and we're going to find the length of the missing side in a right triangle. So you have several triangle problems. You know, you have area, or if you have similar triangles, so you have 2 triangles, you find a side. When we find the length of a missing side in a right triangle, this is when we use Pythagorean's theorem. So remember, Pythagorean's theorem is a squared plus b squared equals c squared, where c is your hypotenuse, the one opposite the right angle. The other 2 legs are a and b, and it doesn't matter which is which. So that's what we're working with, and we're going to find the length of c. So we're going to plug in what we know. So we have 5, and we're going to square it. We have 12, and we're going to square it. This is equal to c squared. Do all the math you can. So we have 5 squared is 25. 12 squared means 12 times 12 is 144 equals c squared. We'll do the math on the left-hand side. So 169 equals c squared. This is a little bit above our table, so you might have to guess. And we have to do a square root here. We don't want to know c squared, we want c. So that is why we do the square root. So we're doing the square root of both sides. And when we do the square root here, it's going to take, the radical takes the exponent off. That gives us c. For 169, this is actually a perfect square. You might have had to work a little bit, but it's a 13. Right, we have one more triangle. We're going to find the length of the missing side of a right triangle, except this time we're not going to look for the hypotenuse. They gave us the hypotenuse. The 6 is the hypotenuse, so that is your C. The other 2 are A and B, and so we're just looking for a different side. So we're going to plug in what we know. So we called A 3, and we have to square it. B we did not know. And C we know. So we'll work out all the math we can. So 3 squared is 3 times 3 is 9. And 6 squared is 6 times 6 is 36. Now we have a plain equation. We would like to isolate our b squared. So we're going to need to subtract that 9 from both sides. Clean up. So b squared is 27. And we want to get just the b. So we're going to take the square root. Square root of b squared would be just b equals the square root of 27. This one is not a perfect square, so we'll make an estimate. If we have 5 times 5, that is 25. So the square root of 25 is 5. If we have 6 times 6, that is 36, so the square root would be 6. 27 is in between these two, so we're going to guess something between 5 and 6. It's very close to 5. The 27 is very close to 25, so it's going to be close to 5. I'm just going to say this is about 5.1. I would accept any answer between 5 and 6 there. Problems 53 through 64 on this review sheet are actually worked in the equation review that's also with these final exam reviews, so I won't repeat those. You do have a choice with those. I tried to work one in vertical style and one in horizontal style.